All right, then let's talk about optics today. So we have optics around us every single day. One of the biggest example is simple mirror. For example, imagine this black line is a mirror. Let me label it for you. And we have an object. In this case, let's say a single dot on the left of this mirror. And this one is the object that we're going to look at. And then we have an observer located at this location right here. Here's the eye. And so we have to find how the eye sees the object in the mirror. Now, we know that from the object there is actually infinite rays that goes in every single direction. For example, we have rays that go in this direction, 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 360 degrees. But we have to find the direction that actually hits the mirror in the right spot and goes back to the observer's eye. So now, how do we find it? Well, the answer is actually quite easy. We know that the distance between between the object and the mirror, in this case, let's take this case to start with, is the same distance as the distance from the observer to the uh, mirror. So it's the same exact distance. Now, we also know that the ray will have to hit the mirror at some point and go back right here at the eye. Now, we can find out that uh, the point where the object ray has to hit is easily findable by doing this. Let's find, first of all, the distance between the object and the observer, like this. Let's find, and so we know that the distance between the object and the mirror is the same as the distance between the observer and the mirror. That makes things a little bit easier because we can simply divide this distance in half and then connect a normal, let's say the half is right here, and then connect the normal that hits this line in half to the mirror. Now, we have to connect now with a ray that starts from the object, of course, to the point where the normal hits the mirror. So it's basically a normal to the mirror as well. Let me make it so it's a little bit clearer. Now, this right here will actually go back here as well. How do we know that? Well, the answer is fairly easy, of course, because we know that the side right here, so the distance from the object mirror is the same as this distance here, and we found the distance between the object and the observer, and we divide it in half. So we know that this distance is the same as well. So we know that 2 out of 3 sides are the same as for each one of this triangle. A triangle drawn like this, with these red lines, and the triangle will be the same as the other side. Since 2 sides are the same, the third one has to be the same. And we can see it because it's also in common. So this side will be the same. Now, we know that in 2 triangles that are the exact same sides, also the angle will be the exact same. So for example, here will be 90 degrees, as is pretty clear. Here will be a certain degrees, and here will be certain degrees as well. So let's call this angle alpha 1. If we know this one is alpha 1 and this one, let's call it alpha 2, are the same angle, we know that these two have the same um, are the same angle, so they have the same uh, number in the angle. We can say, for example, it's 30 degrees. If alpha 1 is 30 degrees, then alpha 2 will be 30 degrees. We can find out, of course, pretty easily that this rule applies to also other situations. Uh, the rule is, of course, that every single refracted ray will have the same angle between the ray and the normal as the ray that hits the mirror will have the same angle as the ray that gets reflected. So alpha 1 will always be equal to alpha 2 in case of a mirror. We can find out in a more general situation like this one. So let's start drawing a mirror again. Oops, I'm just drawing more perfectly. All right, so we have a mirror like this. We have an object right here, and we have an observer instead at a different distance right here. So this is the eye, this is the eye, and the object that is located at a different distance in this case will be, of course, uh, will change the angle since something's changed. But how will the angle change? Well, let's find out. So let's find distance in between the object and the mirror. Let me label the mirror. Uh, that the distance will be this distance right here. Now, this distance will not be the same as the distance from the server to the mirror. So now we have a slightly bigger problem, right? Well, yes and no, because the problem can be solved very easily. Now, the distance in between the object and observer is going to be like this. Now, we know that the angle that hits the starts from the object and hits the mirror with the normal will have to be the same angle as the ray that gets reflected from the mirror and goes to the observer with the normal. Now, we have to find out. For example, if we draw this angle right here and then uh, a normal, let's draw it as uh, let's draw it a little bit clearer. Okay, so if we draw a normal line like this, also like this, there's normal to the mirror. The angle in between these two things, oops, okay, and let's call it alpha 1, will not be the same as the angle here, alpha 2. And that is a problem because we know that the angle has always to be the same. Always has to be the same. So what we have to do is actually draw a line that hits a spot in which the normal that is in between two the two rays will have the same angle with both rays. So let's try and draw like this and see if it's the same. Now let me draw normal as in a yellow line. Actually, it's a different line, so it's clear. Let's draw like purple and a little bit. Okay, so this angle here will be the same angle as the angle here. So alpha 1 and alpha 2 will always be the same. This is a rule of reflection. So every time you see a refracted angle, a refracted ray, the ray the angle that is created between the object that starts from the the object that is created from the ray that starts from the object and hits the mirror will be the same angle that is created by the ray that is reflected from the mirror with the normal. It will always have to be the same. This is very easy, and it's just a rule that applies to every single time we use a mirror. Uh, it also applies to other um, objects. For example, we can see in a glass. For example, if we were to see the if we were to see instead of if we were to use instead of a mirror, we were to use a different object, like for example uh, a window. We see part of our reflection. We see our reflection in the window, and the uh, the properties will not change whatsoever. So as I said, these two angles will always be the same. That's a thing that you have to absolutely remember, because that's a thing that will help you solve the problem.